Hello and welcome to this, the sixth and final episode of our Roadsafe Technology for the Safe System webinar series. The series has been organised to explore how connected technologies can contribute to each of the pillars of the safe system approach to road safety. My name is Nick Reed and I'm the host for the series. I work in transport technology and road safety through my company Reed Mobility and as Chief Road Safety Advisor to National Highways. I'm also a trustee of Roadsafe, which is a charitable organisation that brings together government, industry and research organisations to foster collaboration on road safety topics. We're very grateful to Bosch for their support of this webinar series and to Agilicis for their technical and logistical expertise in arranging these sessions. In our previous webinars, we have looked at the contribution of technology to achieving safe road infrastructure, post-crash care, safe vehicles, safe speeds, and multimodal transport and land use planning. In this, the last episode in the series, we're moving on to discuss the role of technology in supporting safe road users. And I'm particularly excited about this one for two key reasons. Firstly, my own background is in psychology and human factors, and I worked for many years at TRL, delivering studies on driver behaviour using simulators, test tracks, and real-world studies. Much of my work now relates to humans and how they interact with automated vehicles, so I have a keen interest in this topic. But secondly, in each of the 5 episodes to date, the behaviour of road users has featured regularly as a critical element. If we build infrastructure that meets the latest safety standards, how do we know road users will behave as we expect or intend them to? If safer vehicle technologies are introduced, how will we know that drivers will use them to maximise safety and not misuse them to gain some other advantage? And in the event of a collision, how should road users behave to maximise the chances of a safe outcome and minimise the risk of further injury, and so on? So I'm delighted to say we have 5 fantastic panellists from industry and academia to help navigate this territory. But before we meet them, we are of course continuing the theme of hosting each webinar at a location that is relevant to the discussion. And today we're being very kindly hosted by Geotab at their Automotive R&D Centre in High Wycombe. For those unfamiliar with Geotab, they are global leaders in the Internet of Things and connected vehicles, providing web-based analytics to help customers manage their fleets more effectively, efficiently and sustainably, processing billions of data points each day. We've made a short film this morning to highlight some of the fascinating ways that Geotab collect data on road users and then put that information to good use.
My name is Russell Cockerton. I'm Senior Automotive Specialist here in the UK. I head up the Automotive R&D team for High Wycombe. We are the central point for Geotab in Europe in terms of automotive engineering. Our main focus is working with vehicles, new and old, to reverse engineer and ensure that we're able to install correctly to those vehicles, to interact with them, and then to ensure that we are able to access the data required by our customers. Key aspect of everything that we do within Geotab, and certainly at Automotive, is safety first. So we want to make sure that whenever we're interacting with a vehicle, firstly we're doing it in accordance with manufacturer OEM guidelines to make sure that we're not causing any damage or any faults to that vehicle. We also ensure that our customers receive the data that they require. So it is a constantly evolving situation. Not only new vehicles becoming available, but we see that manufacturers are making changes to existing vehicles. One of our big OEMs recently introduced a software update to their vehicles, which meant that we had to go back and do some work around to accommodate that change and also to take advantage of the new data that they'd made available. Upstairs you will have seen our Geotab Museum, which is the only one in the world, collected here in the office. It shows the evolution of the Go device from the very first Go 1 back in 2000 all the way through to our Go 9B or Go 9 Rugged, which is our latest iteration. As it's evolved, we've incorporated things like a GSM modem, so now we're able to give live data as that vehicle moves, back in 2003, 2004. And then started to interact with the vehicle itself, not only giving positional data, but engine data or vehicle data. What are the powers of Geotab? And one of the things that we're very, very good at is we're able to assist anybody with any fleet size. So literally from the smallest fleet with 1 or 2 vehicles all the way through to our largest fleets, where we're running literally upwards of 300,000 or 400,000 vehicles in a single fleet, the more data-hungry customers who need to make real-time decisions on fuel economy, on fault codes, on maintenance of their vehicles. So they receive the information from the vehicle. It's not us generating it, we're just providing it to the customer, we're telling you what the vehicle tells us, is the golden rule. So are you able to maintain that vehicle? Does it need a service? Not only do we do normal vehicles in inverted commas, but we also work with customers in extreme situations. So a big project that we worked on recently is with the British Antarctic Survey, BAS. They're operating obviously in the Antarctic, where temperatures are minus 70 degrees, no cell phone network, no formal communications apart from old HF radios or UHF radio. They need to be able to receive a notification of a potential emergency or accident. But they also need to be able to capture that data and review what they've done to optimize their performance, to minimize their impact on the environment.
Fantastic, really inspiring to see the work that goes on here and all the data that is collected and how it's used. So we now move into the discussion and indeed welcome our expert panelists. And I'd like to highlight as well, those of you joining on the Teams call can submit your questions through the chat function, and I'll be able to pose those to the panelists later in the discussion. But first, turning to my right, Aaron from Geotab. So yeah, can you tell us a little about yourself and the company?
Sure. So I won't do too much on Geotab because I think Russell did a pretty good job there. But my role at Geotab is to bring that kind of global scale and engineering expertise to bear for our customers in the UK and Ireland. So I'm responsible for ensuring we have the right ecosystem around the customer to make that data useful, whether that's working with safety related partners or maintenance related partners to distribute the data essentially to add insight and impact for the customer.
Fantastic, thank you, Aaron. We're also joined online by a panelist. We have Lisa from Cranfield University. Lisa, can I ask you to introduce yourself?
Hello, hi. Yes, I've been working in the field driver behaviour for too many decades now, and most of my research has been on the transactional components of driver behaviour, and I've been working at Cranfield University since 2001. Thank you.
Brilliant. Thank you, Lisa. Welcome to the panel. David from Nottingham-Trent, welcome.
Oh, thank you. Yes, I'm a professor of psychology at Nottingham-Trent University and co-founder of eSitu Solutions. And I've done a lot of work on the cognitive aspects of driving, where we look how we pay attention and specifically in hazard perception.
Superb. Thank you, David. Welcome. Neil from Human.
Yep, Neil Kinnear, a lead behavioural scientist at Human. Human is an insurtech using geospatial and behavioural data to price insurance risk in real time. And we use that to also help fleets to manage their risk and to help them become better and safer fleets at the same time. I joined Human earlier this year following 13 years with TRL, where I was latterly the head of transport safety.
Superb. Welcome, Neil. And last but not least, Tony from Lytics.
Thanks, Nick. Yeah, so Tony Pappas from Lytics. So we specialise in video telematics and safety solutions. Currently, my role focuses on partnerships at the moment and looking at our video technology and safety and how we can bring that into the various partnerships that we're running at the moment.
Fantastic. Well, welcome everyone, and yeah, I'm sure you'll appreciate it's a fantastic panel. Really looking forward to the discussion. So, Aaron, I'm going to start with you. I mean, we've heard in the video about some of the ways that Geotab works with vehicle data, but what are the kind of interesting or surprising insights that you've been able to generate in terms of road safety?
I think the biggest surprise is probably how many fleet managers there are out there that aren't really using too much data. So it's, it's a bit of an easy cop out for me to say, but it still surprises me day to day that we can interact with a fleet manager and find that they're not actually gathering any data from their fleets. But the nice surprise is on the other end of the spectrum, how some of the biggest fleets in the world are using this data to protect their drivers and to run their businesses more efficiently. So we have some really interesting examples using some of those things that Russell was talking about, getting rich, deep data from the vehicle, where some of the world's largest fleets are looking even at the granular detail of what the driver's doing when they park their vehicle. So the sequence in which that they turn off the ignition, use the handbrake and put their seatbelt on. Because we have those data points from the vehicle, we're able to help them report on it, and they see significant changes in risk. on whether you put your handbrake on before you take your seatbelt off, as an example, and at which point you open the door. So it's surprising to me both how little data is being used in some cases, but probably more impressively on the other end of the spectrum, how much data can be used and the returns in terms of reduction of risk that can be had by looking into the granular detail of what's happening.
There's a danger here that each answer any of you give will open up a number of questions. I'm kind of interested in, for companies using that sort of data, how do they then turn that into things that would change the behaviours of their staff?
Yeah, so in this case, we're talking about a last mile delivery company, and they are interested twofold. So one is efficiency. So obviously a last mile delivery driver is rewarded for the number of deliveries that they do in a day. But at the same time, from a goodness point of view and a safety point of view, they want to make sure that that's done in the most efficient way. So by having those data points, they're able to coach the drivers. So in that case, we actually work with a couple of other parties that implement some driver coaching, both in terms of person to person after the fact coaching, but also some interaction sort of in the cab and directly after the event. So, at the end of the driver's shift, they can be scored and coached through an application on how they can improve, but also have, at the end of the month or at a review cycle, some more in-depth coaching with data to back that up.
Perfect. Lisa, turning to you, I mean, you'll be well known to many of our audience today, not least for your many TV appearances, but also for your involvement in some of the most important developments in terms of understanding driver perceptions and the measurement of objective driving behaviour. I mean, what are some of the ways you've seen our understanding of driver behaviour change over the last 20 years?
Yes, it has changed fundamentally, really. We've learned an awful lot about driver behaviour, and I would say that one of the main methodologies that has been developed over the last 20 years has been the use of technology. Hitherto, certainly in the 90s, very much a focus on self-report methods, and whilst they are very useful in a driver coaching capacity and profiling drivers, they really don't explain an awful lot of the variance in crash involvement. So I guess it was around about 2005 that I started looking into how telematics could kind of measure driver behavior in a much more objective way. And certainly, the early days, it was very problematic. The batteries would drain, the technology was really quite poor and often, quite clunky. But nowadays, it's incredible, as we've heard, what can be achieved and how much very fine granular data that we can understand. Obviously, telematics doesn't measure everything, but it certainly gives us a very good understanding of how drivers are behaving.
Fantastic, thank you, Lisa. Turning to you, David, I mean, another luminary of the field, and one of the biggest changes that's happened over the last few years, last decades, has been the hazard perception test and the role that that's played in improving driver safety. I mean, can you tell us about the hazard perception test and how we've grown to understand safe driving through that test?
Yes, well, the hazard perception test was brought in as part of the licensing procedure back in 2002. And we've had 20 years now of that test being there, of that test stopping the worst drivers from going on to do their on-road test, but also encouraging people to train in hazard perception. And before we had the hazard perception test, there really wasn't that sort of ethos of learning when you're in the car about what the hazards are. It was much more motor-based. Since then, we know that the hazard perception test has been successful in a number of ways. It's won awards, and we estimate things like 1,000 fewer injury-based collisions per year and nearly 90 million saved to the UK economy per year as well. So it's been very successful in that way, but we need to be expanding that. And certainly we should be expanding it towards the fleet markets, and we should be seeing it have more success overseas. But we are seeing that now with other countries starting to adopt the UK's position on hazard perception and incorporate that test into their own licensing procedures.
So we've had Lisa talking about understanding driving behaviour, and David, you're talking about the licence acquisition process. Neil, I'd like to turn to you and talk about that process of going from being a novice driver to being an experienced driver and what that process looks like. So what do we know? How can we understand what that means to become an experienced driver, maybe from a physiological perspective?
Yeah, so we know that drivers pick up the manual skills really quickly, which is interesting because when we look up what is a good driver, we see things like someone who steers, uses the brakes, steers, uses the gears, brakes and accelerates smoothly would be considered a good driver. But actually, they're the skills that are picked up really quickly. And it's the higher order skills, as us psychologists term them, but the sort of attention, anticipation, perception, it's those skills that we find take a lot longer to develop. And so through the sort of physiological studies and now brain imaging studies that we've done more recently, we identify differences between novices and experienced drivers. And we see that novices lack this sort of bodily response to anticipating risk. So it's that gut feel that you get, which is our, I guess, evolved way of anticipating risk in our environment that we just apply to driving, because we haven't evolved to drive. We've evolved to anticipate risk in our environment, but we use that same bodily system to help us when we're driving. But that takes experience. It's experiential learning. And so while the test is ultimately originally defined to test whether someone has the manual skills to operate a vehicle safely, it doesn't necessarily test those higher order skills to the level at which a driver is the same as an experienced driver. And so you get that situation where you pass the test, and actually we're at the highest risk of being involved in a crash at the point that someone has just said, you're a good driver. So there's a real juxtaposition there. So that's the problem we find ourselves in.
And how can technology mitigate some of those risks?
So, well, one of the interesting ways is we're touching on this use of telematics data in a way now that we haven't been able to use it before. But actually, one of the last bits of funding that I obtained at TRL was a project with some partners in the US, where during COVID, many states in the US actually got rid of the driving test altogether. And they were just allowing people to pass after a period of time of having been on the provisional. And what that opened up was the opportunity to rethink licensing drivers. And actually, when you think of it, the driving test is just a point in time where your performance is judged at one singular point. Actually, what we want to see is how do drivers behave over a period of time. Can you demonstrate that day to day your driving is good enough to be a safe road user and therefore be licensed? And telematics offers you the opportunity to do that. And so the trial in the US will be really interesting to see if that can be applied and if it can actually provide us with the potential to use telematics in a way that can actually license drivers and then hopefully become part of training as well.
And that is a perfect segue to you, Tony, isn't it, really, about understanding what drivers do day to day. So yeah, can you tell us about Lytix's work on fleet safety and the resource that you've built up in terms of understanding driver behaviours and the craziness that's out there, and how Lytix adds value for fleet?
Yeah, sure. So I think, from Lytix's perspective, we see a lot. We are predominantly a video telematics company. We're we call ourselves the pioneers. We've been in the market for 22 years now, which is considerable time, and seen technology evolve and change to having over 800,000 cameras connected, all streaming live video to the platform at the moment. So the business has seen a lot of change, but things are still the same. We're still looking at driver protection and using our solution to really empower the driver to identify risk early. And the last 10 years or so, really, we've been working on what we call machine vision and artificial intelligence. And that's very much around moving from a reactive state of looking at some data, something's happened, and you need to be reactive to do that, to actually being in a position to actually be more proactive with the data now. So in real time, being able to give the drivers an understanding of what's happening in the cab and the risks that they're being exposed to on a daily basis.
And that must mean it becomes easier, the number of cameras you're talking about, to be able to scale your business. You kind of need that machine learning, that AI support. to provide the service?
You do. I mean, we have gone through the process of obviously scale and grow as a business. We understood that we had to, train our algorithms on huge pools of data to become accurate. If you're, showing someone a video of someone using, say, a smartphone, the video needs to be of the person using the smartphone. So, and we're lucky enough that we've built through our own channels, but also through, the strategic partnerships we have in place now, which are global partnerships. And lots of people ask me, is the risk different in different regions? Well, it isn't. It doesn't matter whether it's a left-hand drive car, a right-hand drive car. Risk is risk. Drivers are still being exposed to many, many different things on a road. And that's where we come in to try and, support the driver in those types of scenarios.
Coming back to you, Aaron, in terms of supporting drivers in improving safety, what's the kind of scale of benefit that you've seen when you've introduced some of the technologies we talked about, and it has led to changes in behaviour that have improved safety? What kind of scale is achievable?
Yeah, good question. I mean, coming back to my previous point around how surprising it can be, how little work can be done in a fleet when you first meet them, you can imagine that in that scenario, you're seeing huge scales of benefit. We've had customers reduce their speeding fines by 60% in terms of number of fines per year. We saw a big turnaround in New York City where they reduced their fatal accidents by 28% across the city. They were using the telematics along with some other programs that we're running. But I think in terms of scale of benefit, the numbers speak for themselves. There's lots that we can do. And then interestingly, kind of double clicking on Tony's point around, does it matter if it's in North America or in Spain or in the UK? We actually ran some comparative studies because we'd like to be competitive with our colleagues across the pond. And while we saw that behaviours were slightly different in Canada, maybe there's slightly more harsh braking events in the UK versus Canada. Once we were able to make the trips similar, so look at people that are doing similar jobs, we actually saw a driver that's high risk in the UK and a driver that's high risk in Canada. It's not where they are that's making them high risk, or where they're from, I should say. It's the environment in which they're driving. So are they fatigued from driving for too many hours? Are they driving in very low temperatures, and therefore they should be driving slower and they're not? And that's one of the things that we kind of tried to bring to bear with all of the data that we have from the vehicle, is we can see more than just are you driving quickly? We can see a lot of the context around how you're driving, how long you've been driving. If you're driving a HGV in Europe, we see some of the tachograph information. So we're really able to get into some detail around what's happening to help fleet managers.
And Lisa, turning to you, that raises an interesting point around what we do when we have this data, and how much effort we should be going to persuade those who are resistant to change to change their behaviours. So people who are frequent speeders or don't put their seatbelt on. Should we tackle those non-compliant drivers, or should we focus elsewhere where there might be bigger issues to tackle?
Yeah, it's a good question, and certainly we come across some pretty defiant drivers trying to do their own thing. So I think there are some very hard to reach individuals for whatever reason. But I think that the bulk of the driving population are reachable. I think a lot of the behaviours that you see that are resistant to change are ones that could possibly be managed with better enforcement. But also some of the attitudes can be quite hardwired in, really quite biased, strong beliefs about, for example, seatbelt wearing, that it's actually safer not to wear one. And some of these kinds of behaviours really need to, I think, take a safe systems approach, where you're not just focusing on trying to sort of nudge the behaviours towards safer seatbelt use, but also perhaps taking advantage of some of the technology around. We know, for example, that seatbelt warning reminders with the technology in the vehicle actually has a 9-fold increase in seatbelt wearing if it's fitted into the vehicle. So I think there's a combination here of better enforcement, better education and technology. And
I was going to ask Lisa, is that enforcement, does that sort of almost necessarily need to be technology based? What is the way to achieve enforcement? I suppose it depends what issue, of course, but is there a need to focus on technology because we know the challenges in terms of manpower for enforcement?
No, absolutely. And, you know, I think we all know, don't we, that roads policing is, you know, it's extremely resource intensive, and there is a role for technology here. And, you know, the issue, I think, largely is that people don't think they're going to get caught. And, you know, if we can actually increase the chances of consequences for people's actions, then I think we would have a better chance of containing some of the behaviours that are really, really high risk.
Now, speaking of behaviours that are high risk, Tony, I mean, one of the risks that has emerged over the last decade has been kind of the ubiquity of smartphones and the temptation for drivers to use them. So from your work and from the videos that you capture, how have you seen that risk play out and efforts that have been made to tackle that risk?
Yeah, it's a really interesting subject because I think, you know, technology is evolving around us all the time. You know, so you call it a smartphone, you know, it's a smart social media device now, you know, so we see, you know, many different videos coming through where it's no longer a call might be the cause of a collision, but actually the interaction with that smartphone through channels like social media. So there's other areas of risk that are coming in now into an in-cab, you know, even the technology that sits in the vehicle itself, you know, connected through Bluetooth or wherever it's going connected to. You know, we see that those are streams of distraction that are happening out on the roads today. We know that 80% of all collisions out on the road today are by form of some kind of distraction that happens in the vehicle. Now, we take the view that distraction, smartphone, is one area of distraction, you know, but we're actually looking for other areas of risk that are happening in the cab all the time, for things like eating and smoking and seatbelt wear, like Lisa mentioned. You know, those are the types of distractions that we're continuously monitoring now. But we're using it as more of a tool to empower the driver, because a lot of it is human behaviour. And, you know, the guys will sit here on the panel. It's not that you actually want to make that phone call or you want to do that social media post. It's just that you've been distracted while you're driving. And it can be that split second of distraction that can cause that accident and that collision. So how do we, and, you know, how do all of us get around the table and resolve these types of challenges? So we take the view of trying to very much empower the driver. Rather than wait for the crash to happen or the collision to happen, how can we get ahead of that? And that's really where we've championed the latest thing that we've been working on called FNOR, where we're looking at first notification of risk as opposed to first notification of loss. Why wait until a collision has happened and then go through that whole process? Where we believe that you can notify the driver of the risky events when they're happening through the use of our technology, that then hopefully brings the risk and we start to see that risk coming down and ultimately protect the driver.
And can you do that in a way that is received positively by drivers? I can imagine there might be a resistance, a reluctance, or a feeling of threat that these messages are coming in. What do you mean I'm not driving well? You know, how do you manage that in a way that is encouraging?
There's two answers to that question I most probably can give you at this point. You know, I mean, yes, you know, whenever you're adopting technology in a business, you know, you've got to be transparent with how the technology is going to work in the business for one. Any of our customers, you know, we've seen it, the successful deployments are all around. They've really built this health and safety culture within the business. So it's all about being transparent what the technology does. I think the second bit is, you know, our technology is on the driver's side. That's the first thing. It's not, you know, we are not pushing out surveillance. We're not pushing out CCTV. You know, ultimately, if a driver is, you know, not being risky, then there's no need for any video to be sent anywhere. You know, so ours is really around getting that driver on side. What we do find is obviously if a collision does happen, then the first thing the driver does is want to review the video if they're not at fault, because they know it can exonerate them. So once the drivers get their head around what the technology can do and what it's looking for and how it can benefit them in their daily routines, then they're fine with it.
I mean, that brings us nicely to you, Neil. And I'm interested in your career at Human and how Human's approach is novel and innovating. And is it focused on individual drivers or is it focused on fleets more broadly? How is their approach differing?
Yeah, so the approach is generally that we're looking at the individual, but within the context. So there's the risk that the individual brings to themselves through their own behaviour, but then they're operating within a much wider context and that system in the road transport system. So it's, you know, when they're driving, where they're driving, what's the weather like that they're driving in, what are the conditions, what's the traffic like. So it's using all those geospatial data points and linking that with their actual behaviour. And I guess what's important about sort of this InsurTech type approach is that it does three things. So one, it makes insurance fairer. So you're pricing risk as someone is exposed to, rather than estimating or guessing risk at the start of a policy, that you can actually price it based on the trips that they've done and how they operate in that. And they can make choices on their route type, time of day to do that trip, and how they behave. And so they can manage their costs. So you make it fairer. Tony mentioned empowerment. That the data that you can provide can empower fleets or drivers to understand that risk and how their behaviour starts to impact on it. And so that empowers them to make decisions, better informed decisions on what to do about that, and to identify areas. So we've seen fleets that have identified that their drivers at a particular roundabout were all flagging events. And actually they then spoke to their fleet about what was going on at this roundabout, and all their events then dropped. And so you're actually starting to manage particular risk spots within the data. And then finally, what I think is really crucial is that it brings insurance into the SAFE system and makes it an active part of the SAFE system. So traditional insurance is typically a financial product, and it is just there to, I guess, protect you in the event of loss. So it protects the individual or the fleet in the event of loss. InsurTech is taking that to the prevention level, so it's prevention and protect. So it's there to protect in the event of loss, but actually it's looking to prevent that loss in the first place. Mm-hmm. And that makes it an active partner in the SAFE system, rather than a bystander. So that's what's interesting about it.
That's fascinating. Really interesting. And all of those contextual factors are something that, David, they weren't included in the original hazard perception test, or to a limited degree. But as your work has moved us into the virtual realm, more of those things can be introduced. Can you tell us about the work on virtualizing the hazard perception test?
Yes, one of the big problems with the hazard perception test is that you sit in front of a screen that's that big, and you're watching for hazards. So where are the hazards going to come from? They're going to come from somewhere in front of you, which means it's a fairly restricted area of the world. And actually the hazards that we face in everyday life are much more likely to come from the sides, or maybe overtaking, undertaking. These things we can't capture in a traditional hazard perception test. Indeed, the DVSA clips don't even have any mirror information, so you can't see behind the car that you're driving. So what we wanted to do was to actually take it into a 360 environment. The idea here being that when you're wearing a VR headset, you can look wherever you want to. It's still not interactive. It's still a hazard test at the very heart of it. But now you can look down side roads, you can check your blind spots, and you can see pretty much everywhere you want to around the car. And when we've done studies, and we had a large Road Safety Trust grant that was also part funded by the RAC Foundation, and we compared hazard tests in the virtual world to hazard tests that you just see on a single screen. And what we found was that, first of all, they were more immersive, they were more realistic, as you might expect, but also they were better at discriminating or distinguishing between safe drivers and less safe drivers. And that, at the heart of it, is what a hazard test needs to do. We need to sort out those who we think are safe on the roads because they have got the skills, they've got the knowledge about how to spot those hazards, from those people who perhaps need a little extra training. So by putting people into that virtual world, we then get closer to what that real skill is, because we can't take them out on real roads and see how they interact with real hazards necessarily, not in a test format, although using things with telematics and dash cams nowadays, we can get information after the fact. But again, the whole point with hazard perception testing is we want to do this before the fact. We want to make sure that people have the best possible skills before they go onto the road, so hopefully we're not recording so many crashes with the telematics.
And is it something, well, firstly, is it something you see that this is what the hazard perception test should become? Everyone should go through the virtualized process. And is there a role for it in post license acquisition? Have you maintained your hazard perception skills at an acceptable level?
Yes, I think certainly there is a role for hazard perception beyond actually learning to drive. We know from the evidence that even experienced drivers can benefit from additional hazard perception training. We know older drivers can benefit from hazard perception training. We've done hazard perception assessments with fire appliance drivers. We've been able to sort out those fire appliance drivers who we know have had collisions from those who haven't had collisions using our fire appliance hazard test. So using hazard tests within the fleet world, within older drivers, within basically any driver who wants to keep their skills tip top, I think that's a very important step forward. Now, as to whether the VR is going to become a more ubiquitous element within hazard perception testing, we may be a little away from that. We still have issues with occasional cyber sickness, although a study we recently published actually showed that there was a meta-analysis of 50 studies looking at cyber sickness symptoms within VR driving related studies, and they came up with a range of scores. When we calculated the cyber sickness scores from our VR hazard perception tests, we came just below the lowest score in that meta-analysis. So actually, although we're still getting some cyber sickness symptoms, we are much below the industry standards. So there is hope, but for the time being, we see it more as a formative process rather than a summative process.
I mean, all of this is giving us huge amounts more information about driving and drivers. I mean, from your perspective, Aaron, do we get to a point where there are kind of privacy concerns? Is it overbearing? Is it too much information?
I think that's a common question, as you can imagine. And privacy really comes down to, do you have a purpose to be looking at the data, and is there consent there for you to be looking at it? And I think what we're seeing increasingly now is the drivers are seeing this as a benefit to them. So whether that's because they can win more business. So, as a company, we're able to win more business because a thing we're being assessed on now is how safe we are or how sustainable we are. So having that data from the vehicle helps that. Similarly, as Tony referenced, you've got people at home that want you to get home. So once you start to see instances within the business that, hey, this technology in the vehicle saved someone's life because maybe they had an incident that was unavoidable and they're able to be saved when otherwise they wouldn't have been because maybe they're in a remote destination. And similarly, as we can step back, and I think the onus is on technology to be able to step back through gears, as it were. So, when a business is first getting into using technology, maybe you don't want to be recording footage in the cab and sending that to the cloud. Maybe you don't need the location of the vehicle, and actually configuring the technology in a way that it can be scaled back to look at what's necessary now. So, using Geotab as an example, because we read so much from the vehicle itself, we don't need to base many of our metrics or any of our metrics on GPS. So we have some great safety programs in place in countries like Germany and France, which are, famously, more difficult to operate in from a privacy point of view, where we're not using GPS at all. Actually, they're very effective programs. And as we start to step through those programs, now you're saying, well, should we use GPS just if we think you've had a crash? So now we've got your location and we can feed that to the emergency services as an example. Once you start to come over those barriers and show the benefit, the privacy concerns start to melt away. And similarly, if nobody's looking at all of the data. So it's as you start to report by exception and start to be able to scale it up and down, those privacy concerns become less and less.
Yeah. And Tony, I saw a corner of my eye, you were nodding away to a lot of that. I mean, I know from my work with truck drivers and on telematics and vehicle external and internal cameras, there's an initial reluctance, right? This is spy in the cab type responses. But in a short space of time, they come to actually appreciate and demand that technology is installed. Is that your experience as well, and similar, in terms of privacy? How do you see drivers responding, fleets responding to the challenge around privacy?
Yeah, well, again, Aaron makes some really good points. It's about technology adoption, and you can imagine video is, like I say, it's quite emotive, or can be quite an emotional experience looking at someone on video or having a camera in the cab. As with all, similar to what Aaron mentioned, we've done deployments throughout across the globe now in many EU regions where the market is really at its early adopter stage. And what we found is, by marrying up the technology for that region, it allows you to overcome some of those barriers. So as an example, we provide technology as like lens as a sensor. So our internal lens is not actually recording. It's not actually recording video. Right. All it is working as a sensor that's looking for risk that's happening in the cab. So we might identify risk as a smartphone being used. We might not take a video of that, but we might alert the driver that we've alerted that this is risky behaviour. So it allows them to correct in that moment. So it's getting through some of these barriers to adoption and working with the workers' councils and the unions, because ultimately they should be there to protect their drivers in making sure that they come home safe at night. And that's what our technology is all about. But agree, you've got to start at somewhere, and it is not a case of going in there and saying, right, we're just going to open up all the technology now and away you go. You have to go through steps to adoption eventually, and then as you get to a wider audience, or some lighthouse accounts and big name logos start adopting this technology and build it into their company health and safety policies, then you're into kind of the mainstream for sure.
And Lisa, turning to you, we've been talking about measures taken in the interest of individual drivers. What about the things that we might introduce at a more systemic level in terms of road safety that drivers might perceive as kind of imposing on their freedom? How do we persuade drivers that measures taken in the interest of safety genuinely are to their benefit and not somehow challenging their freedom to drive?
Yes, I think we do need to start to consider these things because, you can see after the recent pandemic how, the state has a duty to protect the health of its people. And, largely when you're driving in a vehicle, the risk is externalized to those people around you. It's the vulnerability of pedestrians and powered two-wheelers and cyclists that we need to consider here. So it's really about making sure that drivers are aware of that juxtaposition between the sort of freedom to travel and go wherever you want to and when, for how long you want to drive, given all the constraints that need to be put on that, what restrictions and limitations need to be taken into account. The traffic system's highly regulated, to allow you the freedom to be able to travel, but it has to be done safely. Now, how you set that up so that people understand that there is a shared responsibility that we all have as road users is going to be challenging. And the only real way that you could do that is to set it in the context of how the traffic system has developed. So looking at, for example, how the volume of traffic has changed over the last 20 years. It's significantly increased. You've got a hybrid of different types of road users around you. And it's about understanding the change in technology as well within the vehicle, and the limits of the regulations to try and curtail the risk. So really, I think my answer to that, and it's largely a philosophical question really, is that it's about education, and that's probably the best way to go.
Thank you, Lisa. And I'm struck by how there are different populations of driver, and we need to address their needs specifically on a group by group basis almost. And with that in mind, David, I mean, motorcyclists, a group that are at objectively higher risk on the road. What do you see as the future of safe riding behaviour? And with gig workers and the demands placed on them to make as many deliveries as possible in a short space of time, how can that be managed safely?
Well, it's a big problem. One of the hats that I wear, I'm part of the small group of psychologists and who work with UK RoEd designing courses, and one of the courses we're redesigning, refreshing at the moment, is the National Rider Risk Awareness course, and so this is being developed for all motorcyclists who might break the law in certain ways, and this includes both your leisure riders, your commuters, and your gig economy riders. Now, of course, they will all break the rules for different reasons, so we have to be aware of those reasons. And then we have to try and make them accept their behaviour and then change their behaviour accordingly. And that's the tricky thing, to try and get cyclists, or motorcyclists in this case, to actually change behaviour. We can certainly improve skill. And again, things like you would expect me to say, hazard perception, could play a role in there. But of course not the hazard perception that all drivers face at the moment. Whether you're getting a HGV license or a motorcycle license, you're still sitting the same hazard test that looks like you're driving in a car that's normed on learner drivers. We need specific hazard tests, specific to the vehicle, specific to the role. Our fire appliance test was filmed in fire appliances. Our HGV test is filmed in HGVs. We did a test for motorcycles years ago. Again, that was recorded from motorcycles. So we can, with specific tests, risk-taking tests as well, look to improve skill behaviour and risk calibration. But we also need to appeal to these riders in order to address their behaviour in certain ways. And part of that is getting them to acknowledge that their behaviour doesn't necessarily fall within the norms of what other people, even within their in-group, might consider to be normal behaviour. That's the big challenge that we have at UK RoEd, writing those courses, and I think it's one that permeates throughout the road safety fraternity.
I mean, in terms of that, building that understanding that the needs of different groups, Neil, I wondered, is there data to which you would like to have access that you can't access currently? Is there something that you think could really transform our understanding of road safety, either for individuals, for particular groups, or for fleets more broadly?
I mean, it's probably an endless list, isn't it? The obvious one is data from the vehicles that is still very much, sort of behind barriers, and I think, as the video at the start mentioned, manufacturers will update systems and then everyone else has to work around that. And as vehicle technology becomes more connected, and so when you're connecting vehicle to vehicle and infrastructure, etc., it feels like we need to have streams of data that are actually core, that are released by all vehicles, that these can be managed, these can be used, publicly available, and innovation can develop around it. It doesn't mean that manufacturers can't still develop their own IP and the systems around that, but actually the core streams of data should be used for the purpose of managing the road network and improving safety and efficiency of the network, and all the benefits that would come with that. It still baffles me that there can be a fatal collision and collision investigators still can't access some of the data from a vehicle. That seems incredible to me, but it's that sort of thing needs to open up. But I think from a psychology perspective, and it's that understanding of the wider aspect of people's well-being and their lives, and how transport plays a role in that. So someone turning up at work who drives for work has a whole life going on outside of that, and all we ever monitor or try and manage is what's happening when they're in that vehicle. But actually there's many things in their life that we have no clue about that's going to influence the way they behave on that particular day in that vehicle. And And often we might feedback their behaviour from telematics, etc. But actually, it's their well-being that we don't understand. And actually, I'd love to know the data around that. What's, how well have they slept? How are they doing in life? How are they? And I'm not sure many people ask that question.
Again, that gets us into that the territory of privacy and intrusiveness of the data collection and how it would need to be managed properly if you're going to start exploring those types of data. But if we are collecting more and more information, whether it's data from vehicles, whether it's video, does it scale? If we're having data from millions of vehicles, video from millions of vehicles, can this data-led initiative, a data-led enterprise, scale to every driver?
Yeah, I think it can. Looking at Geotab as a business, we have something like 50,000 customers now with 3 million vehicles connected, driving around, and that generates 50 billion data points a day. We've built our business to scale so that we're focused at those very large fleets. And what that shows is with the correct architecture and the correct way of thinking about things, you can not only make it scale technically, but also make the privacy of it scale. So, we use those examples there where maybe you're turning off an internal lens, maybe you're turning off GPS in a certain country, but also on the other way around. So it's interesting. One of the most interesting privacy conversations I've had in my career was actually recently speaking to an insurer that's in North America and in the UK. And in North America, the things that they're considering as an indicator for risk start to go in that direction, not quite to your sleep quality, but, how are your mortgage payments? They collect so much information about a person that just doesn't happen in Europe because of the different legislation that are in place. It's interesting to see the outcomes of that. So is their book of business less risky because they're collecting that data? Well, actually no today, because they've got it and they just price the insurance differently. They're not interacting with the driver. So I think it can scale. I think the technology out there today shows that you can gather a lot of data. It's just then about applying that in a scaled way. So turning that big pot of data into some insight that can actually influence what's happening with the driver. And we're seeing, lots of things appearing in the market, including some of our products, which are taking that, let's call it big data, and giving some actionable insight to a fleet manager here in the UK or in Ireland based on what's happening all over the world in a private way that's applicable to their market.
I mean, I know there have been questions coming in from online. I will get to those in a minute. And it will build into the discussion very nicely. But before we do that, I just wanted to ask a couple of questions related to this point of kind of evolving technologies. Maybe, at least if I start with you on, it's a personal one for me almost, the evolution of automated vehicles and how that might change driving behaviour. Firstly, initially, as vehicles do some of the driving some of the time and gradually expands from there. Do you see any risks, challenges in that process?
Well, we've recently won a fairly large-scale project funded by PSRC and UKRI to investigate behavioural adaptation to automated vehicles and autonomous systems. And one of the things that we're particularly focused on is the unintended consequences around the use of this kind of technology, because we know virtually nothing about the long-term effects of systems like automated lane keeping systems, for example. Even if you just look at some of the standard lane keeping assistance systems that are not automated, you can see behavioral adaptation within a very short space of time. And my concerns from a psychological perspective is that whilst on the face of it all this new technology can be seen to be beneficial, certainly in the laboratory, my question is what happens out in the wild? How do people develop their habits around the technology? We know that it takes a while for habits to develop. On average, it's about 66 days before you really see habits fully developed. So what kind of unrealistic expectations do we have around automated systems and autonomy generally? People can be overconfident in the technology and not be prepared to take over when it can't do the job it's supposed to, or fail to monitor. So these are some real concerns that we're starting to investigate at Cranfield.
I wish we had 3 more hours to continue that discussion, Lisa. One of the questions we've had come in, and it's one I'm keen for, maybe Aaron, you start, and others can build. To what extent should we be sharing? Should companies that are collecting data for fleet purposes or for insurance purposes, should we be sharing that to roads authorities in the interests of safety or network management?
A lot, I would say. So it's difficult to label an extent, but if you can share the right data. So I think the common fear is, I'm a driver. I don't want my location shared with the police, as an example. I don't want my speeding data shared with the authorities. As long as we're able to segment that data and make it useful and non-identifiable to the relevant authorities, I think it's incredibly important that we start to do that. And it's something that Geotab works hard to enable. So that's, aggregating those large sums of data that I spoke about before and slicing it in a way that's relevant for a local authority, but also aggregated in a way that is not identifiable at all, so that the people, essentially paying to generate that data, paying for our services and collecting it and running their businesses with it, only see positive outcomes in terms of, improving the quality of the roads and the safety of the infrastructure around them.
And another question that's come in, and I'll probably address this one to you, David. We've focused a lot on driving and drivers, but how can we use technology to improve the safety of vulnerable road users, others who are in the vicinity of roads, using the roads, pedestrians, cyclists, horse riders?
Yeah, well, there's been a lot of concern amongst certainly the horse riding community about AVs and their ability to actually detect horses and riders in the roads. And I share their concerns. Admittedly, if we can, for instance, if we take on board the new legislation, the new rules about passing horses, passing cyclists with a 1.5 metre gap for cyclists or a 2 metre gap for horse riders, 10 miles an hour for horse riders, 15 miles an hour for cyclists. In theory, if you have an autonomous vehicle, then that has that rule built in, and it will only overtake when it's safe to do that. That seems like that would be a very good opportunity to make the roads safer for those vulnerable road users. But we have a great many degrees of freedom with vulnerable road users. They're much more variable in their behaviour than, say, more robust road users like the cars and the trucks. And therefore, we have to make sure that if we are going to ever rely on algorithms to make sure that these vulnerable road users are protected, that we have to really make sure that they are dealing with all potential outcomes. And I do think in terms of some of the more exotic vulnerable road users, we're a little far away from that at the moment.
And very quickly, Tony, I mean, in following on from that, you must have videos of the sorts of interactions with vulnerable road users that could be used to help train automated vehicles, that could help for training of human drivers, for that matter.
We do, and I think it's autonomous vehicles is a really interesting subject. We have a mantra that no driver is ever the cause of a collision. I don't think we're ready to change it yet to no robot is ever the cause of a collision just yet. We see the driver as still at the forefront of the technology. They really are. They're the biggest asset to the business and the technology. How we use that data and how we move that technology into other areas is obviously, something that we're looking at. And we see more and more coming to Aaron's point, we're starting to integrate more as businesses together than we ever have done. And that for me is really key. It's not about having siloed data sets. How can we bring data together into one single platform that then gives so much value to our partners, to our customers, and the end users? And that should be the ultimate goal that we're all working towards, because then the types of conversations about what you do with the data become a lot more easier, because you're not having to go to so many different places to source the data.
Well, Tony, that is a perfect end to the episode and the series, actually. That need for collaboration and co-working around data, around technology to improve road safety for all. As I said to Lisa, we could go on for many hours discussing these topics. It's been a fantastically enjoyable conversation. Thanks so much to all of the contributors today. Really enjoyed the discussion. Thank you very much to Bosch and Agilysys for their support of this webinar series. And of course, thanks so much to you for watching and contributing to the discussion at home. It's been a pleasure to host the series. Wishing you all safe journeys and goodbye.